After you've installed the engine and you're ready to break the engine in, you go through the break-in procedure, and then you're out operating on your own. You hopefully, again, done all the things that you need to do by the operator's manual or suggested manufacturer's information about how to install the engine properly and get long life from it. If you fail to do these things or use improper products or things that are operational sequences that may cause the engine to fail, you'll run into particular problems. Well, we're going to show you some of the effects of these problems and how and why they happen. We have a situation here where a piston will always tell you the condition and the operation of your engine. I use piston reading technology to determine why engines fail, and from the products or the operation of the engine we can usually determine whether or not that operators have done things properly. If you look at the damage that we have occurred with this particular piston, we see a total damage area, whether it be on the intake or the exhaust side. This indicated some sort of a failure from a product or oil that may have not lubricated the engine properly or caused the rings to stick totally, and then the flashing of the oil on the side of the piston starts to affect the lubrication quality. So lubrication and oils will definitely improve the life of your engine depending on which ones you're using. Fuel is a big portion of that. Most of our mix is fuel. So higher octanes will eliminate problems with two-cycle engines that we will show you some results of later. Our second example is a sticking area along the exhaust side of the engine. The exhaust side of the engine is usually the hottest area. The exhaust gases are passing out through the exhaust port and into the exhaust system. If the piston shows signs of sticking on these areas, usually the result is from not warming the engine up properly. In the liquid-cooled engines, we want to run upwards of 140 degrees before we actually accept full throttle from the engine. In air-cooled engines, about 4 or 5 minutes of warm-up will normalize all the parts. Remember that we have an aluminum piston, we have a cast iron cylinder, we have high-quality crankshaft parts. All these parts have to expand to their proper size and operational temperatures before they will work properly. So in this instance, usually what happened was the engine was not allowed to warm up properly, and it forced the piston into the cylinder walls. This requires a replacement and usually an etching of the aluminum material in the cylinder walls. We have another situation here in a detonation. We talked about the ignition system and how timing is important. If we advance the timing too far, we can pre-detonate the fuel, and therefore it turns into more heat and erosion of the piston than actual performance. A lot of performance people will try to advance the timing as much as they can. Our prescribed timing points are important and should be adhered to. This will, the timing advance or a bad ignition system can create this problem. Our next example is of damage from particle damage internal of the engines. Bearings or parts that are loose in the engine and will damage it. Usually what happens is the transfer ports in the engine will take the fuel charge up on top of the piston. Well, along with the fuel charge, it will take particles along with it. And any loose particles in the engine will go to the area where we're actually compressing. This compression area will be a small area, and if the part is large enough, it will create damage to the piston. those are a few of the things that happen, again, with product type things or operator type situations. The operator's manual tries to show you how to operate the engine properly, and if you operate the engine properly, you should get to the 300-hour TBO point where I get to see your engine.